Okay, so today we want to look at graphs of sinusoidal functions, right? And we kind of looked at that yesterday. Now we want to go over some characteristics of it. Okay, so we'll take a look at these characteristics. So we know that we have an equation that's of the form. You don't have to write this down because this is going to be basically, it's sort of at the top of the page there. I just want to go through it with a slightly different view. We have an equation of the form y equals a sine bracket bx plus c close bracket plus d. So what's d? The median or the midline. Where's the middle of this graph? Between the maximum and minimum, probably about halfway, yeah. So where is it? What's the value? 1. So, all right, there's 4, right? So that's as high as we go. We go as low as -2. How far apart are these guys? 6 units. Where's the middle of 6? 3, right? So we have a maximum value of 4. We have a minimum value of -2. To get the distance, you don't have to write this down, it's on the sheet, right? To get the distance between maximum and minimum, you subtract. Now, that's going to give us the middle, right? We take the max value minus the min value. That's how far apart. But we want to be in between those, right? We want half that distance. So max is 4 minus -2. 4 minus -2 is 6. Or sorry, yeah, 6 over 2. Wait. Yeah. Oh, sorry, I want plus.
Yeah, we're doing.
Yeah, we want the average, right? We want the middle, which is the average. We've got to add the 2 together. So 4 plus -2, which is 2, over 2, which is 1. So you say, okay, so the middle's at 1. Now, a lot of times when you're doing stuff like this, it's good to graph the midline, right? Even if you're just sketching it on yourself. And just make sure, does that look like it's in the middle? Yeah, right? You look at this and you say, well, yeah, if that's the middle, then yeah, that's symmetrical, right? It's like same distance above and below. So the d value of this equation is 1. The equation of the midline itself is y is equal to 1. Right? You have to write this down. It's all on the sheet I gave you. Once you've just wandered in, then you should come get the sheet. Okay, so y equals 1. Now, what's the amplitude? It's the distance from the middle to the max, or the distance from, because it's in between, the distance from the middle to the minimum, right? That's going to give you the a value. Now you can just count this, so what's the a value? 1, 2, 3, right? But maybe the numbers are too big to count, right? Like we're doing the Ferris Wheel one. You don't want to be sitting there counting from 80 down to wherever. So in this case, we want half of the distance. So the distance is max minus min, right? So the average is adding the two numbers together. The distance, what we want is the distance from here to here is 6 units, and the amplitude is half of that distance, so it's going to be 3. So we take max minus min for minus -2 over 2, which is 6 over 2, which is 3, right? So that tells us this distance in here, the amplitude is 3. Right? So that's 3 sine. Okay, so now we want the b value. Well, the b value is not the period, but it's related to the period, right? So what's the formula? And you can look at the sheet in front of you. What's the formula that relates b and the period? So what did it say? B is equal to 2 pi over the period, right? So b is equal to 2 pi over the period. So like, where are we getting everything from? We're getting it all from the graph, right? From the graph, we have a maximum value. There's still seeds. And the maximum value is 4. From the graph, we have a minimum value. And the minimum value is -2. from the graph, we can figure out the period, right? So period, we could start here. So start at the midline going up. That's where a sine function starts. And remember, period split into 4 parts, right? Climbing up to the maximum, back to the middle, down to a minimum, back to the middle. So what's the period here? Pi. So the period is pi. So the b value will be 2 pi divided by pi, which is 2. So we have, now the c value, remember c value is the phase shift. So is this graph shifted? So when we say, all right, is there a shift? What we want to look at is 2 things. We want to look at the midline, and we want to look at the start point. So if it starts at the midline and it's going up, then there is no phase shift, right? If I shift it, then this would be moved. So we got to find that midline. That's why I always draw it in, right? If I could see the midline. So we're saying, all right, this is going to be y equals 3 sine 2x plus 1, right? So from the graph, we figured out the d value, right, which was the average, 4 plus negative 2 divided by 2. We figured out the a value, which was half the distance. Distance is max minus min over 2. We figured out the period. We didn't figure it out. We looked at it. We got the period here, and then we said, all right, so the b value is 2 pi divided by that, and we got the b value equals 2. So if I scooch this over, you should be able to see that I graphed 3 sine 2x plus 1. Okay. So that's where all that comes from, right? Now, what we want to do is look at all of this, but in relation to some graphs. So the worksheet that you have is, here's a graph. Can you come up with the equation from the graph, right? Can you come up with the values for A, B, C, and D? All right, so here we go. Given this equation, it's on your formula sheet, right? Y equals A sine bx plus c plus d. The equation of the midline, now it's a line, right? So it's got an equation. It's y equals, right? Go back here, right? This is the line, y equals 1, right? There it is there, y equals 1. That's the blue line. So it's got an equation, right? So what you're going to do is figure out the maximum value and the minimum, right? So you're being given a graph. So off that graph, you're sorry, it's got a maximum value of this, got a minimum value of this. Once I have those two numbers, I could say, well, the middle is halfway between, and I can calculate it, max plus min over 2. If you get this wrong, it should be pretty obvious, right? You're looking, like when I went the wrong way, I was getting 3, and saying, ooh, that's not it, right? The middle, definitely not 3 here, because I was figuring out the amplitude, and I was going to say, well, here's the midline. Yeah, that's not a midline. Okay, that's a nothing. That's the line y equals 3. It makes no sense, right? So when you figure out the midline, you'll look at the graph and you say, all right, I draw that in. Yeah, that's about in the middle, right? If I'm trying to draw it up there, it's like, I think maybe I figured out the amplitude or something. So to figure out the midline, you go max plus min divided by 2, not on the formula sheet. Okay? The only thing you get on the formula sheet is this and this. Not this, and we're not going to use it. Once you've got the midline, you can get the equation of the midline simply by going y equals this, or just go y is equal to d. Okay, so you figure out the d value. D is the median, or the midline, or the middle. Okay, you want the equation of that. It's y equals d. Amplitude, half the distance between max and min. Distance is maximum minus minimum. That's how far apart the two things are, right? So 4 minus negative 2 told you they were 6. If you're just given a simple graph, you can just count it. Just make sure you know what the scale is, right? Anytime you're looking at a graph on quiz, test, diploma, worksheet, whatever in the book, if you're counting, make sure that the scale is not halves and you're counting by ones, right? That would just be wrong. So just make sure you know what the scale is if you're just going to count. So you can count the amplitude. If you can figure out the midline simply by counting. Say, all right, it's 6, so I'm just going to go back up 3, draw my midline. I want to count for the amplitude. I'm just going to go from the midline and just count up or down to the max or to the min. But we can calculate it, right? Max minus min over 2. Or the distance from the midline to either the max or the min, right? So that's amplitude. You find it a couple of ways. Period. The length of the interval of the domain, that means the x values, right? The horizontal axis, that's your domain. To complete one cycle. So one cycle, you can start anywhere and end. Okay, so I could start here and end here. That would be one cycle. I could start here and end here. That would be one cycle. Give it up?
Oh yeah, already.
Okay. Yeah, I did this twice. So one cycle you can do from a peak to a peak, right? From a max to a max, from a minimum to a minimum, right? Because if you start at the max, you're going to have to go through a cycle to get back to the maximum again, right? How many pieces in the cycle?
4.
4. Good. Yeah.
3.
No, there's 4. I was just holding up 3 fingers. Get somebody to say 3. It's like, think, don't just, Okay, it's 4 pieces, right? So if you're starting at the max, the 4 pieces are down to the midline, to the bottom, to the minimum, back to the middle, back to the max. Okay? Start point, though, is here. That's called our start point. So the start point is defined as where the curve intersects the midline, so you got to find midline first, right? And is going up. Going up. Okay? You can also do a cycle from here to here, right? Curve intersects midline going down. You just need to go back to the same point in the cycle, right? At the same point on the graph where we're intersecting the midline going down, then I need to get back there. And I will go through how many pieces to do that? 4, right? Okay, so I will go down to the bottom, back to the middle, up to the top, back to the middle, right? So you could do one period. Now, if you're given something like this, you're going to have to figure out the scale. So you just say, well, here to here is pi. So I've got 1, 2, 3, 4, 5, 6, 7, 8 pieces make up pi. So the scale must be pi divided into 8 pieces. So pi divided by 8, right? So this is 1/8, 2/8, 3/8. But if I want to count the period, I'm going from here to here, I just say 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces gives me pi. My period is pi. I'll use that to calculate the b value. Okay, let's clean this off. Now we'll get on to the sheet. Okay, and last thing is the start point. Start point of a sinusoidal function is where the graph intersects the midline and is first going up. Okay? Now, so by first going up, let's go back here again. So what I'm going to do here is just flip the start point a little bit, right? I'm just going to move it. So I'm going to move it to the left. So I moved the start point to here. Right, I moved it left. How much? I moved. That was 1, 2, 3, 4. Oh, right. Sorry, I changed that because of that 2 in there. Bing. Okay. So I moved it to the left, pi over 8. Okay. You can't tell that here, right? Nor are you expected to, right? So in 30-2, we don't worry about phase shifts. We should look at it and say it has been shifted. Okay, we can look at the graph and say, oh, it's been shifted 1 tick, so it's been shifted to the left, right? So when we say start point, right, we're looking for intersection of y-axis and midline, right? That's where you should be starting, at the y-axis midline intersection and then going from there. This is moved to the left, pi over 8. Now I could move this to the right, pi over 8. So now it's moved to the right, pi over 8, right? 1 tick to the right. So all you need to know is this graph, right? I'm looking for midline, y-axis, and that's where the starting point should be. That's where the graph should start. If it does, there is no phase shift. If it doesn't, there is a phase shift. And I'm just going to ask you to worry about saying, yeah, it's been shifted right or left. We're not really going to worry too much about how much. Except today, we will a little bit. So we'll go through the formula and how to do it, but you won't be expected to do that on the exam, right? Because they're not going to give you, because they'd have to give you the formula. The formula would look like this. So the start point of a sinusoidal function is graph intersects midline first going up. The coordinates of the start point are negative c divided by b, comma d. So the d part makes sense because you're starting at the midline, right? So your y value has to be the value of the midline. And your start point, if you're given the equation, you take the negative of the c value and divide it by the b value. That will give you the x coordinate of the start point. So we will play with that a little bit today. Okay, applications. Ferris wheel, the graph shown below. So everybody, every sinusoidal, if you look up sinusoidal equations on the internet, you're going to run into a Ferris wheel. Everybody does a Ferris wheel as an example of a sinusoidal. So I'm just going to zoom this a bit so that we can see the whole thing. So if I take that to 100, we go a little bigger probably. 125. That sounds good. Oh, that's good. Okay, Ferris wheel. The graph below represents the height of a person on a Ferris wheel. Everybody's been on a Ferris wheel, right? Or at least seen a Ferris wheel. Who's it named after?
Ferris.
Guy named Ferris. Exactly, yeah. George W. Ferris. First came out at the Chicago Exposition in the late 1800s in Chicago. I think this is actually the original Ferris wheel. It was like 80 meters tall. They didn't build small stuff, right? It's not like the kiddie Ferris wheel at Heritage Park kind of thing, right? This sucker's 80 meters tall. That's pretty close to a football field tall. Each car held like about 40 people. Okay, so again, remember, this is not like a two-seater. You get in, you sit inside, or like the Stampede, where it's like 6 of you can fit in one of those little things. Like, you know, this is like bigger than the London Eye. Not taller necessarily, but the cars held more people, right? And it took a couple minutes to go around. His idea was just, hey, what if I take a bridge, but bend it into a circle, right? So that's exactly what he did, right? He took a bridge like they would have built a bridge, and he just made it into a circle, mounted it on a hub, stuck an engine somewhere to drive the thing, and then built the cars for people to get in, and away you go. So, person gets on the Ferris wheel, x equals 0. So our x-axis is actually time. Okay, so time in minutes, and the y-axis is height. So maybe we could have called this t for time and h for height, but we're mostly going to deal with x and y. So, what is the height of the Ferris wheel when the person first gets on it? So here they are, they're getting on it. How high is that? 2. Okay, so you look at the scale and you say that's 8, and it's 1, 2, 3, 4, and 8 divided by 4 is 2. So each tick on here is 2. So this is, so let's go here, we're going to list this, right? We'll just say the minimum value is 2. Okay, so we have a minimum of 2. Minimum 2. What's the maximum? 82. So the max value is 82. Right? Because if we're going to figure out the middle, we do not want to sit there and go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 46, 28, 30. You don't want to count it out by ticks. Probably you'll miss one anyways, then it'll just be wrong. So we want to calculate this, right? Want to be able to calculate. So where's the middle? What's halfway between 2 and 82? You don't even have to count, just do it. Okay, what's halfway between 2 and 82? 42, right? So the calculation is, we're going to average them, right? I just need, so the middle is the average, right, of two numbers. The middle of two numbers is the average of the two numbers. But we have a formula, right? So the formula is D is equal to max plus min. So how do you get an average? You add them together, and then you divide by how many there are, right? It's just two numbers that we're averaging. So we're just going to add together max plus min, divide by 2. So that's equal to, well, 82 plus 2 over 2, which is 84 over 2. Which is 42. So that means we should be able to go here, find 42, draw a line. I got a straight-ish line. It's a straighter line than I've ever drawn. But I was just following a line, not even all that straight. So you draw a straight line of 42, and now look at it and say, does that look like the middle? Like, am I off? And if, so I'd say, all right, it might be off, but it's pretty darn close. All right. So this is the midline, and it has an equation of y equals 42. So if I ask you for the equation of the midline, don't write 42. Right? Y equals 42. Right? It's a line. So, but we have a d value, right? D. I don't know why that switched to red. Oh, that switched to red because that got dropped in there. Okay, so we got d is equal to 42. Okay, A. What's A? How far from here to here? So from 42 to 82 is? Yeah, 40, right? So A is 40. Now, we have a formula, right? Formula is A, the amplitude is max minus min over 2, right? It's half the distance from the maximum to the minimum. The distance is found by subtracting, right? So if I want to go from 82 to 2, it's 82 minus 2. So 82 minus 2 over 2, which is 40, it's 80, well, it's ultimately 40. It's 80 divided by 2, which is 40. So A is equal to 40. D is 42. How many quantities are there in the formula y equals a sine bx plus c plus p? There are 4 of them, right? A, B, C, and D. How many do we have? We have 2. Oh, hang on, I'm ignoring this. What's the height of the person? So what's the height of the Ferris wheel and the person gets on it? 2 meters. What's the minimum height of the Ferris wheel? 2. Why 2? Why not 0? I mean,
Because when you get on, it's like a little above the ground.
yeah, it's got to be above the ground, right? We don't want this thing scraping. And if you go to the one at Disneyland, which I think loads below ground, right, so that they can. Yeah. What is the maximum height of the Ferris wheel? Did this, right? Was it 82? Yeah, 82 meters. What's the equation of the midline? We did that, right? Y equals, was it 42? Okay, don't throw an M on there, right? So if we are talking about the y-axis, then we're measuring stuff in meters, right? It's 82 meters high. You get on at a height of 2 meters. The middle is at a height of, 40, well, we haven't really got there. So the equation, what's the amplitude? 40. Now, really, it's 40 meters, right? Amplitude is actually measured in meters because it's on the y-axis. What is the radius of the Ferris wheel? Here you go, key question. Nobody in the province can figure this stuff out. Let's see if you guys can. What's the radius of the Ferris wheel?
42.
Okay, so what would the radius of a wheel be? Where would you be looking on this? So I'm looking at the Ferris wheel and I want to know what the radius is. What am I looking at?
The middle to the side.
The middle. Okay, so where's the middle? Yes, and we have that number. Where's the middle?
42.
42. And what's the side? Be at the top or the bottom? It's 40. So what is the radius? It's the radius is 40 meters. What can you say about these two things?
Do the same thing.
Is that a coincidence? No. So, remember this. Could be worth a mark for you on the diploma. The radius is the amplitude, right? So if you're given a circle, and it's got a function, right? So if we take a vinyl record, everybody knows what a vinyl, like an LP? Yeah. If we take, I can show you pictures, or we can go to the museum. There's a big sale of vinyl on that. Some people like vinyl. I do listen to that.
What's vinyl?
Yeah, what's vinyl? The inside of your car is mostly vinyl. It's a petroleum thing, but there's not enough demand for it to raise the price of oil. So, if you look at an LP, a vinyl record, if I say, what's the radius? Where are you looking from? There's a hole in the middle to the edge, right? So that's the radius. If I take that vinyl record, stick it up, and say I have a fancy turntable that's vertical, right? It starts spinning like that. What's the amplitude? You're measuring from the middle, which is the hole, to the edge. So radius, amplitude, same thing, right? So if you run into a question on the because seriously, I was looking at questions that had been field tested, and they had one that was really based on radius and amplitude, and it tested out that about 30% of the people in the province figured that out. And it was like a seriously easy question, right? It's like radius is amplitude. What's amplitude? It's the A value. They gave them the equation and said, what's the radius? The number's right there. There's no calculations to do. There's nothing, right? It's just look and say, it can't be that easy, right? This is how people get it wrong. It can't be that easy, so I'm going to go for one of these other wrong, I'm going to go for one of the wrong answers. So some of the questions are that easy, right? So you look at it, you say it can't be that easy, you say, all right, 40 of them can't be that easy, but 4 or 5 of them can be that easy, right? It is just an easy, straightforward question. So radius and amplitude mean the same thing, right? Now we go back here. This thing doesn't have a radius, right? This isn't a Ferris wheel. It's an equation. Okay, so we can't say, oh, the radius of this. That makes no sense. This is not a round thing, right? This is just a graph. It has an amplitude of 3, but that's it. Okay, this is a Ferris wheel. Ferris wheel has a hub. The hub is in the middle, right? Like any other wheel. Bicycle wheel has a hub. Your car tire has a hub, which we call the what? Technical name for the, no, it's cap you put on. What do you mount it on? The axle. Okay. Sure, they don't teach automotives here anymore, right? What is the height of the person after 1 minute? How are you going to find that?
You could read it.
You read the graph. So, what is the height of the person after 1 minute? 40. So you go to 1 minute, right? This is time. 1 minute, you go up to the graph, it hits here, you come across to here, and it's not 40, it's 42. 42. It's a height, so it has units with it, right? So if we are talking anything to do with height, okay, now here's the question. Of y equals a sine bx plus c plus d, which of these 4 quantities have a relationship to the y-axis? Okay, so does A have anything to do with the y-axis? The amplitude, which we're measuring in meters along the height, which is, yeah, so the A has to do with the y-axis, right? What else? Okay, so the amplitude and the midline are y-axis things, right? So they're measured in y-axis units. So if it's a contextual question, as in it's not just, hey, here's a sinusoidal graph, answer something about it. It's like, here's the graph of a car tire going around, or a Ferris wheel, or something. Then you say, well, these guys have to do with the y-axis, so they'll be in y-axis units, right, which is meters. How long does it take for one revolution? Oh, how long does it take? How long does it take for one revolution?
4 minutes.
4 minutes, right? So how do you get that? So I started down here and I get back down here. It took 4 minutes before I reached my starting point, right? You could do it from here to here. You could do it from here to here. But, you know, really, in this case, it's kind of easy to just do it from there to there. So 4 minutes. What is the period of this sinusoidal function? So f is to e as I is to h. What's the period of the sinusoidal function? Say it out loud. Say it louder. 4. 4 what? Minutes. This is this, right? The length of time for one revolution is the period. So it's 4 minutes. What is the value of B? What's the formula for B? B is equal to, look top page, what is it? 2 pi over the period. What's the period? 4. What's 2 pi divided by 4? We'll go with pi over 2, right? Because I'll leave it like that, it's exact. So the period is 4 minutes. Where do you get the period from? You just look at the graph. How to figure out the period? Just look at a spot and say how long does it take to get back to that same spot, having gone through everything else, right? So period is really easy. Like if you start at midline, you could always go, there's one period right from there to there. You say, no, that's not one period. You have to go through all of the values. If you do the period going from here back to here, you have to have gone through all the values. If you do the period going from the maximum to the maximum, you have to have gone through all the values. How many pieces of the graph will you go through as we define the pieces? 4. Right? You're going to go through 4 pieces. So just make sure when you're figuring out period, especially if you start here, that you say, okay, 1, 2, 3, 4. That's the 4 pieces that make up one period, right? Everything's split into 4. Okay, we got a b value. So the value of b is pi over 2. Okay, flip the page. What's on the next page? What are the coordinates of the start point? Okay. Start point is where graph meets midline going up. What are the coordinates of that point? 1 and 42. The coordinates of the start point I gave you as a formula. So being as the diploma's not going to ask that, if I'm going to ask you stuff to do with the c value, I'm going to give you that formula, right? Start point is negative c over b. So if we want to figure out what's the value of c, okay, that's where we're starting, right? We got this formula. I'll give it to you, right? Or if they want it on the diploma, they'll give it to you in the question. So the start point is negative c over b comma d. Okay, so the d, we already know that's 42. That means that negative c over b must be equal to 1. Okay, make sense? Just taking the things that are in the same position. The first coordinate of the start point is 1, and it's negative c over b. I can multiply both sides by negative 1, so let's simplify that. C over b is equal to negative 1. Now, which of b and c do we actually already know? We know b, right? Okay, so we can go c divided by pi over 2 is equal to negative 1. So c must be equal to negative pi over 2. Just multiply both sides by pi over 2, right? I need to get rid of what's in the denominator. To do that, I multiply both sides by pi over 2. This goes away, and this becomes negative pi over 2. So c. So what's the value of c? We have negative pi over 2. What is the equation of the sinusoidal function? All right, so we figured out a. What's a? 40. Sine. We figured out b. What's b? Pi over 2. Figured out c. What's c? Okay, so we're going to go plus negative pi over 2 or just minus pi over 2. And we figured out d. What's d? Plus 42. Okay, let's do this. Let's get out our calculators. Calculator. Okay, so let's do two now. Calculators should be in radian mode, right? The calculator at some point is going to be cleared. We want it, and it needs to be in radian mode. If you're in degree mode, this doesn't work. Let's set the window so it matches this graph, right? So we're going to go from, let's say, negative 1 to 9. So that'll be our x values, right? Negative 1, positive 9. We'll go by ones. Our y min, let's go from, what do we got, 2, 4, 6, say negative 8 to 84. And what's our scale? 2's. Okay, so go by 2's. Never touch the x-res or anything else there. Okay. Go to y equals. Now we want to put in the equation that we just came up with, right? Which was what? 40 sine. Okay, let's put a bracket down and we'll go second function pi divided by 2. Okay, let's close that bracket. Then throw the x in. Let's go minus, throw a bracket in and go second function pi divided by 2. Close that bracket. Close this bracket. And what was our d value? Plus 42. Okay, so I hit graph. What should I be looking at? Pretty much the same thing that we have there. So starting down there, peaking, we got 1, 2, 3, 4 minutes, right? Took 4 minutes to go. We got 8 minutes, so we're actually seeing a couple of rotations of this wheel. Okay, so did we get the right equation? Sure looks like it, right? I like to throw in one more thing, which is what? The midline, right? So I like to throw in the midline so that I can see, is it really in the middle? And, you know, it also gives me, if I want to know the start point, then I can go here and go second calc, intersect, and say, actually, you know what, I'm going to move along the straight line because it'll be faster. So I want the start point, which is about here, 1, 2, 3. 1 and 42. Okay, so we have that. So, summarizing the Ferris wheel. The d value, really easy to find, right? You average the max and the min. Just add them together, divide by 2. The a value, really easy to find. You just take the difference between the two, max minus min, divide that by 2. The b value, you gotta do a little more work. You have to figure out from the graph what's the period, right? How long does it take to do one cycle? Then you got to go 2 pi divided by b. Okay. Sometimes we might just do it as a decimal, right? In this case, we didn't. We just said, it's exactly pi over 2, so why not? My calculator has a pi button. I can do that. I could have entered it as 1.57. So I could go back here and just say that's 1.57. Get rid of that x minus 1.57 again. That's pi over 2. Delete that. Hit graph. And it's going to be very slightly different, right? Because pi over 2 isn't exactly 1.57. I mean, there's other numbers, but it's pretty darn close. Okay, so there we go. So I think that's pretty neat, right? I mean, all we did was we just looked at a graph and said, where's the middle? What's the amplitude? What's the period? Oh, okay, what will that give us for value of b? And the start point, that's a pain to work out, but okay, the start point, so we did a little manipulation. We got the c value. We plugged it in. It's like, hey, we got the exact graph, right? Where we saw its graph, and we figured out the characteristics based on the graph, and from that, we got the equation. So, let's do it again. Another thing that repeats. So, math teachers like Ferris wheel because everybody's seen a Ferris wheel, right? They all know what they look like and how they work. Most people have been on one, and you get an idea, right? That, oh yeah, okay, so you go up and you go down, right? Your height varies with time, okay? And so we can draw that. Now, another thing that varies with time is the tide, which we have extraordinarily little experience with in Calgary because there are no tides here. Right? We don't have a large body of water. But if you've ever been to the ocean, and you'll notice that if you pick up a newspaper or something, you'll see the tide tables. Right? And that's because people that have boats and sail, they need to know the tide. So the tide is just the height of water in the harbor or in the ocean at any particular time. And that varies because of what governs the tides on Earth? The moon. Right? I know, lunacy. But it's the moon. So it's the moon that controls the tides, right? Because there's gravitational attraction between the Earth and the moon, and that affects the tides. Now, in this case, they're just giving us numbers, and what we're going to do is plot them on this grid and then draw a sinusoidal function, and then use our newfound skills to figure out D, then A, then B, then C, come up with an equation, plot it, and say, wow, it worked again, right? So, in Aberdeen Harbor, wherever that may be, the maximum depth of water is 22 meters, occurring at 1 a.m. and 1 p.m. as shown. So that's shown. That's this point here, 1 a.m. and 1 p.m. So this is, this will tell us here, it's hours after midnight, right? So 1 p.m. is 13 hours after midnight. The minimum depth of water is 6 meters, occurring at 7 a.m. So we got 2, 4, 6. This will be 7 and 6 meters. So we're going to plot that point there. And 7 p.m. What's 7 p.m.? 19. Okay, so there's 18, 19, 2, 4, 6. Okay, watch the scale. This is by 2s. This is by 1s. The depth is 14 meters at 4 a.m. So 4 a.m. is 4 hours after midnight, and we've got 14 meters, so there. At 10 a.m., which will be 10 hours after midnight. And 4 p.m., what's 4 p.m.? 16. And 10 p.m., which is 22. Assume that the relation between the depth of water, y, in meters, and the time, t, in hours, is a sinusoidal function. Okay, and generally speaking, you can model the tides with a sinusoidal function, right? So on the graph, in which t equals 0 is midnight, plot the key points listed above. Connect the points to form a sinusoidal function. Okay, so one big thing, if you're drawing a sinusoidal function, it's a curve, right? Every part of it is curved. There are no straight lines. You can sort of get away with a bit of a straight-ish line, but don't V, right? In other words, if you say that's the maximum, don't come up to the maximum, so don't draw it like this. Right? You're not just joining those points. You're drawing a smooth curve through the points. Okay, so if I ask you to draw a sinusoidal function and you V it out, then you're going to lose some marks, right? You have to understand it's not a V. Okay, so I want to start here. I want to come smoothly down to here and then up to there. So okay, so I messed up this a little bit here. And I moved the whole thing. Okay, right? You're going to draw something. So if you're drawing something for a test or whatever, make sure that you show the points and then draw the best line you can. If the line's not perfect, but you got the points in the right place, I'm not going to ding you anything, right? Because I sure as heck can't draw a line through the points. Okay, so you do the exact same thing, right? What's the max? 22. What's the min? Minimum is 6. So this is how you're going to do any graph you get. First thing you do is figure out what's the max, what's the min. You're going to calculate D, right? D, first thing you figure out is the middle, right? Max plus min over 2. 22 plus 6 over 2. 28 over 2, which is 14. Okay, then go draw in the midline. So calculate the midline, done. Calculate the amplitude. Okay, so what do we do for amplitude? So we go max minus min. Now, you know, if you're just having to state the equation, you may not have to show any work, right? On the problem, you're not going to have to show any work. It gives you all this information and says, you know, the equation or the value of D in this is, and they're going to give you 4 numbers, or the value of A. Does a tide have a radius? No, it's not a wheel. Okay, so things that have a radius have to have a center and an edge, and the tide doesn't have a center or an edge, right? It's just numbers. Okay, So A is max minus min over 2, which is 22 minus 6 over 2, which is 16 over 2, which is 8. Okay, state the period. What's the period? So we can just look from here to here. How long does it take to go from there to there? Period is, and there's units associated with the period. What are they?
Wait, really? What's the X thing?
It's like, what's the period? 12 hours.
Wait, why is it cool? I did. Oh, is it starts there?
Starts, well, the first peak is at 1, and the next peak is at 1 p.m., which is 12 hours later, or it's a time of 13. 13 minus 1 is 12. Okay? So you can go peak to peak, you can go from the minimum, so 7 to
Wait,
here.
the second peak is 13 now.
What?
Yeah, this, like the top of it is 13.
Yeah, 1 p.m., 13. 1 a.m., 1. You're going from 1 to 13.
You said that was 12.
How far is it from 1 to 13? That's where the 12 comes from. Okay. So the period is this distance here, right? Now, you can label stuff like this. So if I don't ask you to algebraically determine, you could just label this, say D is 14, you can go here, you can say A is equal to 8, right? Just counted it, 2, 4, 6, 8. You could say here's the period is 12 hours, right? So just go period, 12 hours. Okay, start point, where the curve first starts going up and meets the midline. So here's the midline. At what time does the curve first start going up? 10. So it's 10 comma 14.
I just don't understand how it's 12 because there's not a peak there.
Peak where?
At 12.
No.
It's on 13.
Okay, where does it start? Where's the first peak? If you look at your graph, where's the first peak?
Oh, okay. Yeah.
All right. Been hit by a sudden.
Wait, no, but I still don't understand.
The light bulb went on, but it went off. It's a compact
You
light.
can just see
Okay.
the second peak, but like.
I'm
second
saying, how
peak
long
is
does it take to
long.
get from the first peak to the second peak? How many hours to go from here to here?
Oh, you know what? I get it now.
I'm gonna wait though.
Nice or dot?
There isn't. Take a closer look. Where's the dot?
Okay. Get it now.
Still wait. All right.
Yeah,
Yeah, wait. Yeah, no, you're not gonna fool me. Okay. No, all right. I'm getting dizzy now. So the start point is at 10. Okay, so we can label this start point is at 10:14, right? So we know the 14. That can't be a surprise. It's got to be in the midline. Now, if I want to write the equation, okay, so we've got the period. We need to get the b value. How do I get the b value from the period? So b is, we got a formula, right? 2 pi divided by period, which will be 2 pi over 12, which is the reduced fraction is pi over 6. And if you want that as a number, now that's not the period, right? That's the b value. So as a number, it really doesn't do you any good. It's like, well, what do I care if it's 0.5, whatever, right? That doesn't mean anything. The period is 12 hours, means something. I mean, if I look at the graph, it's going to take, there's a distance of 12 between successive peaks or successive valleys. You call valleys or minimums, right? Okay, so we got A, we got B, we got D. We need to get C. So this is where it's going to get kind of messy. I'm just going to go to another page. We'll work out C. So the start point is negative C over B comma D. And we are given it as 10 and 14. We know the b value, right, is pi over 6. So b equals pi over 6, previously calculated. So we know that negative c over pi over 6 is equal to 10. C over pi over 6 is equal to negative 10. And we're going to multiply both sides. So it'll be negative 10 pi over 6 or negative 5 pi over 3. Just reducing, right? 10 over 6 is 5 over 3. So we got what? A is, what was A? 6 or 8? 8. B is pi over 6. C is negative 5 pi over 3. And D is 14. I want to do two things then, right? We're going to go back a page. Okay, we got this. So we want to set our window to match this, right? Okay, so go to y equals. I'm just going to clear out what's in y equals. I'm going to go to window. So we're going to go like negative 2 to 26. Yes.
Oh, so when we use 10 as D, how come we wrote 14 as D in the equation? Or we're getting to that?
No. The start point is 10, 14.
Yeah.
Negative c over b is 10.
Okay.
So did I do that on this page? Okay, so negative c over b is 10. I'm putting in the b value, right? That's 10. I'm going to multiply both sides by negative 1. I'm going to multiply both sides by pi over 6.
Yeah, I don't know that makes sense. All right.
Okay, so there's, this came from the previous page, this page. Okay, so we're going to go back a page in a minute. So I'll give you a chance, you want to copy that down, right? So the hardest thing that you would have to do on this stuff is working out the c value, right? So we can give you easy stuff. Just if there's no phase shift, then you don't have to worry. C is just 0, right? So then it's pretty easy stuff. And then we're going to look at a few of them at the bottom of the page and just figure it out from there. Right? Just matching graphs with the equation. I'm not changing the page. I'll check for no messages is good messages. Okay, so just let me know when you're ready to move. I'm going to pause this. Okay, so two things. Oops, too far. All right, so we want to match the window that's there. So we're going negative 2 to 26 by 1s. The y values will go from 0, like negative 1. I don't know. It's like negative 1 up to how high? So 29 maybe. To 29 by 2s. Okay, leave the x res the same. So we're going to y equals. We're going to put in our formula. So a was 8, so it's 8 sine. Okay, the b value was pi divided by 6. So put a bracket in, go second pi divided by 6, and close the bracket. Okay, so we're putting the b value in, but we're just putting it in parentheses, right? Then the x. Minus 5 pi over 3, so you can do the same deal, bracket, 5 pi divided by 3. Okay? You need to close off two brackets, right? So this is bx plus c, right? Only we're going plus negative. And then we've got d, which was 14, so plus 14.
That's 4.
And that's still 4. You don't have these problems when you're using a for reals calculator.
For realsies.
Okay, and I'm going to graph the midline again just because I like to see the midline, right? So we'll let this go. 14. Okay, so does that match up? Well, I could look for the start point, right? That should be a 10, so I can go second calc, intersect, and just move back down here, go back, go back, go back. And we got 10, 14, right? Okay, so again, what did we do, right? Given a graph, we figured out the value of D, of A. We got the period, we used that to calculate B. We got the start point, we used that along with the period to get the value of C. That would be the hardest thing that you'll have to do algebraically. Okay, last, matching. Match each graph with one of the equations listed. Now, there are 4 graphs, there are 8 equations. So that means that not every graph has an equation, right? So, A equals 1/2. I guess the best thing is to look at the graph, figure out like maybe the A and the D value, and then look at the equations, say how many of them have an A and a D that match those, and then if there's more than one, figure out more. So here, just sketch in the midline, right, which is at 1. So you could say D equals 1. What's the A value? A equals 2. Okay, so I've got a 2 and a 1, so that could be it. Okay, now it starts at the midline going up, so it's not shifted. It's not one of the cosine graphs, right? Remember, the difference between sine and cosine is a phase shift of 90 degrees. So the answer is B, right? 2 sine x plus 1. This is actually in degrees, so you're not going to see anything in degrees, but it's still 1 cycle, 360 degrees. The B value would be 360 divided by the period, which makes a B value of 1. That has a B value of 1. Okay, let's go to this guy. Where's the midline? 1. So D is 1. What's the A value? A half, right? It's like a half. Okay, so we're looking for an A value of a half and a D value of 1. It's got a really weird period, right? Like, so if you go 360 degrees, how much of the period are you seeing here? So in 360 degrees, which in degrees should be 1 cycle, how much of the period am I seeing? Quarter of it, right? Because all we did was go from the middle up to the max. So that means that the B value is going to be, so the B value is how many periods, how many cycles there are in 2 pi or 360 degrees. The B value is going to be 1/4, right? It should be 1/4 of a. Which, if that's the case, means that that's not the answer. 1/3. Oh, 1/3. Okay. Yeah, so we're not actually, we'd have to look and see. Yeah, okay. So what's the, okay, hang on, let's wipe that out. Okay, so, all right, actually half the period, so half the period is 540 degrees. So the full period is 1080. Okay, so if we go B is 360 divided by 1080. 1080 is how many rotations? Snowboarders. 10, actually, well, is that one period? 1080 is 3 rotations, right? So the B value is going to be 360 over 1080 or 1/3, right? So this is A. That's B. Okay, here we have a D value of -2. We have an A value of how much? 3. So it's this one. Oh, wait, could be this one. Right? So they both have an A value of 3 and a D value of -2. So now we're going to go to the period, right? So the period of this would be from here back to here. So the period is pi. The b value is 2 pi divided by pi, which is 2. So I want a b value of 2, so this is h. H. And this guy, so we've got a period of 2 pi, so the b value will be 1. Got a middle of, looks like -3. D is -3. A is 1. Sorry, 2. B is 1. So I want an a value of 2. Could be that. I need a d value of -3, so that one's good. That's it then, right? So even though it's a cosine, it's the only one that had the a and the d value, the correct a and d value, right? So it's cos, and you won't be asked to do cosine graphs, okay? But you might see a little bit in the book. Okay, so what you want to look at is 8.3. Go in and look at some of the examples, the summary, right, the key ideas, and then just make sure that you're able to do the questions that are in there. Whether you do them or not, just at least look at it and say, yeah, okay, I know what I'm doing for this one, and I know how the graph matches up with the characteristics, the values of A, B, C, and D. Sometimes they'll talk about range. So in the book, if they talk about range, they're just saying that it goes from a minimum, so the range here would be from -5 to 1. Right? So it's the low value to the high value. That's what they mean by range. And that's